Hello and welcome. Our task for today is to solve this 2001 German Math Olympiad problem, which says to find the value of Q if the roots of this quartic equation form an arithmetic progression. Now, let the roots be R1, R2, R3, and R4. At this point, we have to talk about Vieta's formulas. Vieta. Now, these are a set of equations that give us the relationship between the roots of a polynomial equation and the coefficients of the polynomial. For instance, if we have a fourth order polynomial, like so, ax raised to the power 4 plus bx raised to the power 3 plus cx squared plus dx plus e is equal to 0. Then, this tells us that if the roots of this equation are R1, R2, R3, and R4, then R1 plus R2 plus R3 plus R4 is equal to minus B over A. Now, it also tells us that R1 times R2 plus R1 times R3 plus R1 times R4 plus R2 times R3 plus R2 times R4 plus R3 times R4 is equal to C over A. It also tells us that R1, R2, R3 plus R1, R2, R4 plus R1, R3, R4 plus R2, R3, R4 is equal to minus D over A. And lastly, it tells us that the product of the four roots, because remember, this is a polynomial of order 4, so it must have 4 roots. I forgot to say that. The product of the 4 roots, that is R1 times R2 times R3 times R4, is equal to E over A. So having these 4 things in mind, and remembering that the polynomial we are trying to solve is also a fourth order polynomial, it simply tells us that the sum of the roots of this polynomial must be equal to 0. Because remember, this polynomial has no term in x cubed. We have x raised to the power 4 minus x squared. So, since it has no term in x cubed, that simply means that b is equal to 0. So that for this polynomial, we have that the sum of roots is equal to 0. Now, that is the first equation we are going to use. Likewise, it tells us that the product of the roots of this polynomial must be equal to q, which is the constant term. So the second one, this is equal to q. So we will be making use of these 2 equations in solving this problem. Now, at this point, we will remember that we were told that the roots of this equation form an arithmetic progression. So if we have A, you remember our arithmetic progression. A is the first term. Then the second root must be A plus D, where D is the common difference. The third root must be A plus 2D. And the fourth root must be A plus 3D. But remember that we were told that the sum of the 4 roots must be equal to 0. So we have that A plus D plus A plus 2D plus A plus 3D is equal to 0 according to Vieta's formula. Here we have 1, 2, 3, 4. We have 4A plus 1, 3, 6. 6D is equal to 0. So we have that 6D is equal to minus 4A. And we have that D is equal to minus 4 over 6A. That is equal to minus 3, sorry, that is equal to minus 2 over 3A. So now we can find the roots in terms of A only because we now have an expression for D. So let me write it out here. We have that D is equal to minus 2 over 3A. So that tells us that the four roots, we have A, of course. And here we have A plus minus 2 over 3A. That is minus 2 over 3A. That is the second root. Here we have A plus 2 times that. That is A minus 2 times 2 is 4 over 3A. And for the third one, we have A minus 3 times 2 is 6 over 3A. So we have that the four roots of this equation are A. 3 times A minus 2, that is minus, or rather plus A over 3. Here we have 3A minus, this is minus A over 3. And of course, this is A minus 2A, which is minus A. So these are the four roots of this equation. Now we write this out. X raised to power 4 minus 40 x squared plus q is equal to 0. Remember that when you have the root of an equation, if you substitute that root into the equation, you get 0. So that simply means that A raised to power 4 minus 40a squared plus. Now remember that q is the product of the roots. So we simply multiply everything here. So we have a times a, that is a squared. And here we have minus a times minus a, that is another a squared. So we have a squared over 3 times 3 is 9. And of course, this is equal to 0. Multiplying both sides of this equation by 9, we have 9 a raised to power 4 minus 360a squared plus a, sorry, this is a raised to power 4, is equal to 0. This plus this is 10 a raised to power 4 minus 360a squared is equal to 0. We can solve this equation for a. First of all, we divide both sides by 10. So we have that a raised to power 4 minus 36a squared is equal to 0. Notice that this is the difference of two squares, because this is a squared squared minus 6a squared, and of course this is equal to 0. So we have that this is equal to a squared minus 6a into a squared plus 6a, and this is equal to 0. So from this we have that a squared minus 6a is equal to 0, or a squared plus 6a is equal to 0. We can factorize. We have a into a minus 6, and this is equal to 0. And from here we have that a is equal to 0, or a minus 6 is equal to 0, and hence a is equal to plus 6. And from here we have the same thing, a into a plus 6 is equal to 0. So we have that a is equal to 0, or minus 6. So we have these two. Of course, 0 is a trivial solution. This is when we come back to this formula to find the common difference of the arithmetic progression. So we have that d is equal to minus 2. When a is equal to plus 6, we have 6 over 3, and that is minus 4. So when A is equal to plus 6, we have D as minus 4, giving us the arithmetic progression as 6, the first term, minus 4, 2, minus 4, minus 2, minus 4, minus 6. So these are the four roots of the equation. And when A is equal to minus 6, we have D is equal to minus 2 into minus 6 over 3, and this is equal to plus 4. So we have A as minus 6. Remember, this is the common difference. Minus 6 plus 4, minus 2, plus 4, 2, plus 4, 6. So we have the same set of roots. But remember, we are looking for the value of Q, and Q is the product of the roots. So we have that Q is simply equal to minus 6 times minus 2. That is 12 times 2 times 6, 12. Q is equal to 144. Now let us substitute 144 into this quartic equation and see if we get the same roots. So when we solve, we have x raised to power 4 minus 40x squared plus 144 is equal to 0. To solve this equation, we can do a substitution. Let y be equal to x squared, where we have that y squared minus 40y plus 144 is equal to 0. Of course, we can factorize this. So we have y, and we have 36 and 4. But because of this, minus, this times this is plus 144. This times this is minus 4y, and this times this is minus 36y. This plus this is equal to 40y. So we have that y minus 36 multiplied by y minus 4 is equal to 0. From where we have that y is equal to 36 or 4. But then you remember the substitution we did, that y is equal to x squared. So we have x squared is equal to 36 or 4, which means that x is equal to plus or minus root 36 or plus or minus root 4. So x is equal to plus or minus 6 or plus or minus 2, which is exactly what we got. So that brings us to the end of this exercise. I hope you learned something today, and I hope you were entertained. See you in the next one.